Well, a warm welcome indeed to anyone joining. Thank you for being here. Go ahead and get yourself ready, as usual. Grab yourself a notebook, a pencil, or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have yet another SAT-style problem. Seems like I can't get away from this topic of algebra. It is an interesting topic. I enjoy writing some of the questions of this style. I've made them progressively harder. If you haven't checked out the other videos of a similar topic, feel free to go check them out. They're very similar in structure. And take a gander at this problem we have here. I did put some multiple choice options there for you to check out. Give yourself about 2 minutes to see if you can solve this one. I will admit this is finally dipping into the tougher territory. So you're going to have to think quite a bit on this type of a problem. We also have some fractions, everyone's favorite mathematical object to work with. So as usual, you can pause the video, give yourself time to try the problem. Then when you're ready, unpause the video. You can come back and see how it was done here. But to give you a little hint, in case you need it, I can do these types of problems all day, every day. That's your hint. All right, let's get started. So we're told that x plus y is equal to 7 halves. We're also told that x cubed plus y cubed is equal to 55 over 8. Now, if you watched the previous video, and if you've been watching the last few, or if you're just an astute math student and you focus and are very aware, you'll know that this, of course, is not simply x plus y cubed. X plus y cubed is not simply x cubed plus y cubed. A student who's not thinking about this very clearly would say, what do you mean? It says cubed, so I cubed everything inside of the parentheses. That's what you're supposed to do, right? No, that lacks an understanding of what this cube means. It means x plus y times x plus y times x plus y. So we are still going to use x plus y, and we are still going to cube it. It's just not equal to x cubed plus y cubed alone. There are some other features. And we opened this up last time. If you haven't already memorized the expansion, like I told you to, memorize the expansion. The expansion is properly written as x cubed plus 3x squared y plus 3xy squared plus y cubed. Now that will, all of that will equal to 7 halves cubed. But we're looking for xy. And the tough part about this problem is that even if you know the expansion, it may not be obvious how to get xy by itself. We see all of these other objects here. We have x squared y, and it's times a 3, and we have xy squared, and it's also times a 3. Well, for now, let's clean things up by using the given information. We know that x cubed plus y cubed equals 55 over 8. So I could say that this is 55 over 8 plus 3x squared y plus 3xy squared. And this is all, of course, equal to 343 over 8. So I can simplify my equation with a little fraction work. And I made the fraction work pretty light, even though there are fractions involved. It's really just a scarecrow of fractions. They're not there to make anything that much more complicated. Just there to intimidate you. And this, of course, is going to be 288 over 8, which, if you're good with your multiplication and division, you can break this down. If you're not comfortable with dividing by 8, first of all, come on. But really, if you do need some support in dividing by 8, just remember that 8 is simply 2 times 2 times 2. Since 8 is just 2 times 2 times 2, dividing by 8 is just dividing by 2, then dividing by 2, then dividing by 2. Really simple. So in case you're not sure how to quickly divide by 8, just cut it in half, right? 144 over 4. Then cut it in half again, 72 over 2. And then cut it in half again, 36. Really not bad. Same goes for multiplying. You can just multiply something by 8 by multiplying the number by 2, and then by 2 again, and then by 2 again. Very easy to do. I see basic arithmetic skills just vanishing. They're just getting sucked out of people's faces, basically. Okay, let's continue with solving. So we still need to find xy. So where is xy? Anyone found xy? Do you see them here? Well, what we should do is we should take this remaining object, as weird as it may look, and we should factor it with the greatest common factor. You notice we can take a 3 out of everything. In fact, let's do that now. Let's divide everything by 3. But we can also take an x out of everything, can't we? Because there's an x squared here, which means it has 2 copies of x. I can steal one. And here we have an x. I can steal one of those copies. Similarly, we have some copies of y that I can take. There's 1 copy of y there. I can steal it. And there are 2 copies of y with the y squared. I can take one. What does that leave me with? Well, that leaves me with one of these x's, and that leaves me with one of these y's, and that's it. So now we begin to see the xy. There it is. There it is. It's right there. We just need to isolate it now. So divide both sides by 3, and don't forget that we know what x plus y is that was given to us at the beginning of the problem. So we have 7/2 times xy equals to 12, right? And now you can finish the problem by simply multiplying both sides by 2 and dividing both sides by 7. And we get that xy equals 24/7. That was my little hint that I can do these problems all day, 24/7. All right, so I think this was a much less obvious application of this concept I've been emphasizing, called the freshman's dream, where it would be really convenient and also wrong, but it would be convenient to execute if the quantity x plus y cubed were simply equal to x cubed plus y cubed. That is not the case. You should look into your sum and difference of cubes equation, and you'll see that this factorization of x cubed plus y cubed is not the same as the expansion of x plus y cubed. All right, so some good clean fraction fun there. Let's circle, box the right answer. And I hope this was a wake-up call if you thought you were good at the problems that I've been showing you in the past few videos, but you couldn't solve this one. That just goes to show you that there's always a learning opportunity. You should never stop learning. I think that's enough blab out of me, don't you think? I'll see you guys next time.